I'm about to solve a problem that's guaranteed to be on your calculus exam. This exact question shows up every single year, and most students still get it wrong. But I'm solving it in just 10 minutes and showing you how to get full marks. Let's get started. S is displacement. And when we take the derivative of S, it becomes S prime, otherwise known as velocity. So S prime is equal to velocity. When we take the derivative of the derivative, or we take the derivative again, we get S double prime. And what's S double prime? That's acceleration. So essentially, if you know how to take derivatives, you should be fine. You start off with displacement, you take its derivative, you get velocity. And if you take the derivative of that function, you get acceleration. So if I asked you to get velocity and acceleration from S of t up here, all you would do is take the derivative of S of t and then take the derivative of that result. Really easy. Just keep taking derivatives. So let's put this in the corner and solve the problem. So A says determine the initial velocity. Okay, well, we need velocity. Velocity is the derivative of S of t, or S prime. Let's take the derivative of this. So 3t squared minus 18t plus 15. And that 4 becomes 0. So that's velocity. So this question says determine the initial velocity. The initial velocity occurs at the start of the race. When do you start timing a race? At 0 seconds. We're not going to start timing a race 2 seconds in, right? We're going to start at the initial point of velocity, which is at t equals 0. So if vi, or initial velocity, occurs at t equals 0, all we have to do is plug in 0 into our velocity equation, right? So v is 0 is equal to 3 times 0 minus 18 times 0 plus 15, which gives us 15 meters per second. So the initial velocity of the object is just 15 meters per second. Super easy. If you ever see initial velocity, that just means the start of the race, otherwise known as when time is equal to 0 seconds. Okay, B. B says at what time is the object at rest? Or what times? So there could be more than one time the object is not moving. At rest just means not moving. Not moving refers to velocity, right? It refers to speed. What is your speed when you're not moving? Your speed when you're not moving is 0 meters per second. And in this case, we're looking for at what time. So time is our unknown, and we're given this hint here. V is equal to 0 meters per second. That's the initial value. So all we have to do is simply apply that to the velocity equation. So this is v of t. We want to know at what time is the object not moving. The object's not moving when v of t equals to 0. So 0 is equal to 3t squared minus 18t plus 15. Now it's just a factoring problem. So I'm going to pull out the 3, common factor that 3 out, get 3t squared minus 18 divided by 3 is 6t there, and then plus 15 divided by 3 is 5. So now it's just a easy trinomial. 0 is equal to 3 t squared minus 6t plus 15. What are two numbers that add to negative 6 but multiply to, oh, that's my mistake. What are two numbers that add to negative 6 but multiply to positive 5? Well, if we're trying to add to a negative number but multiply those same numbers to get a positive, I think they both need to be negative. So that's just t minus 1 and t minus 5. So -1 times -5, that's a positive 5. -1 plus a -5, we're just adding a negative to a negative, so that's -6. All right, that's great and all. We discovered that object at rest means v equals 0, and we factored this. But how do we actually get the times? Super simple. Now we just take the roots. So v is equal to 0, or the object is at rest, at t is equal to 1 second, and at t is equal to 5 seconds. That's it. So just a quick summary. Initial velocity means time is equal to 0. At rest means v is equal to 0. So write that down. All right. This one most students get wrong. Okay, but once you do it a few times, you should never get it wrong again. It's actually super simple. It just involves some stuff that's not familiar to most grade 12 students. So, to determine the intervals over which acceleration is positive, we need to do a few things. We need to determine acceleration. We need to determine when it's positive, and we need to determine the interval over which it's positive. Okay, so let's do the thing we know how to do and take the derivative. Earlier, we were given s prime of t, or we found s prime of t, which is the velocity, and we found that to be 3t squared minus 18t plus 15. We found that to be this function. Now we need the acceleration, so let's simply take the derivative again. So s double prime of t, which is equal to the acceleration, is just the derivative of the velocity function. So 2 times 3 is 6t right there, and then minus 18, and then that 15 is a constant, so it's 0. Okay, so we found the acceleration. Now it's asking us, when is the acceleration positive? In other words, when is acceleration greater than 0 meters per second squared? And that's just the units for acceleration, meters per second squared. So when is acceleration greater than 0 meters per second squared? How do we write that mathematically? That's when is a greater than 0. Okay, so what is a? A is 6t minus 18. So when is 6t minus 18 greater than 0? Now it's just an inequality. How do we find the interval at which it's positive or greater than 0? We simply solve for the input. The input is t. So let's solve for t. So 6t is greater than positive 18. T is greater than 18 over 6, meaning t is greater than 3. What does that mean? That means that acceleration is positive when time is greater than 3 seconds. That's all we got to do. So first, find the acceleration, determine when it's positive, so determine when a is greater than 0, and then just solve for t, and t gives you the interval. Thanks for watching this video. Subscribe if you want to remember me for your next semester's exam. And here's a video on limits, where I solve any limit on your calculus exam.